Hey guys, so I'm going to go through the top 5 questions that were wrong on the Big Ideas classwork / homework that you guys had over the weekend. So these are not in order of the 5 from the worst to the least wrong. It's just in order of how they come across in the assignment. So we're going to go through, like I said, top 5, which is numbers 5, 6, 12, 14, and 20. All right. So the first one, I'm hoping and I'm thinking that the issue is more with the graphing than it is with finding the inverse. Okay, because at this point, it's a nice linear function of finding our inverse. We know we just swap our x's and y's. And then from here, it's just a matter of solving for that y. We would subtract the 1/5. And then from here, your easiest way to get your -4/5 gone is to multiply by the reciprocal, so -5/4. And you multiply it to everything on this side as well. And you would end up with y equals -5/4 x plus 1/4. The 5s would cancel out, which would be my f prime. If for whatever reason it didn't take that, it might have just put it all over a single fraction like this. However, they gave you 2 separate fractions up top. I would assume this would have been a valid answer. Okay, so now we have to graph, and I think this might have been where our issues laid. So I'm going to graph the original in red. I'm going to graph the inverse in blue. So one way, obviously, we could estimate where 1/5 would fall, right? It would be 0.2 up and then move our slope from there. That's fine, completely valid. Or if you really wanted to, you could find whole numbers, points, and use those to graph as well. You can use Desmos to help you out, or a graphing calculator if you have that as well. If you are going to use the points would be a -1, because that would make this a +4/5 plus 1/5 gives you a +1. So I could use that point, -1 over here, and then move my slope in either direction. So it would be down 4, 1, 2, 3, 4 over 5, 1, 2, 3, 4, 5. And then draw as best of a straight line as you can. The computer would do a much nicer job. That's not too bad. All right. And again, for the inverse, if I was to put in a +1 this time, that would give me -5/4 plus 1/4 is a -4/4 or a -1. So 1, -1 is here. And then again, I can go my slope, 1, 2, 3, 4, 5. 1, 2, 3, 4. Or I go the other way, 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay. Again, doesn't matter which way. I just use both so I can get a nice graph for this one. Still don't get a nice straight line, but again, on the computer, it'd be much nicer. And these are also flips. They are inverses of each other. We could even see that from our point, right? 1, -1, and -1, 1. They're flipped. They are inverses. And again, remember, an inverse flips around your y equals x line. So if this is my y equals x, I should have inverse points for each of those. So this point for -3, well, here it is on this side, -3, 4, just flipped around. Okay, so those would be inverses of each other. Okay. All right, next question was number 6. Let's go to that one. Oops. So for number 6, we have our graph. We want to find all points that lie on the inverse. So we are going to want to flip any point, any points that would already be on the line that we see. So I'm going to take a look at the graph here, right? I have a point here. That is at 1, 2, 3, 2. I have a point right here, which is at 2, 0. I have a point right here, which is at 1, -2. I have one right here at 0, -4. And I have 4, 4 up top. So I have all those points that are already there. That is the original function. That means if I was to flip all of them, that one's easy. 3, 2 would flip to 2, 3. You just swap their places. 2, 0 would be 0, 2. 1, -2 would be -2, 1. And 0, -4 would be -4, 0. And that happens to be all of these on the bottom row. Okay, so again, from a graph standpoint, just get the points and then flip your ordered pairs, change your X's and Y's. All right. Let's go to numbers. That's 5, 6. Number 12 is our next one. Okay, word problem. So with the word problems, remember, you do not want to change the letters because then that would change the integrity of the question itself. So we are going to just solve for the other letter, and they kind of gave you that hint right there. So 0.5W plus 3, we know we would subtract 3. You would then divide by a half, or it's the same thing as multiplying by 2. So you would get 2L minus 6 equals W, and that would be our equation for our inverse, for our W, the weight in pounds. Okay, so it says then you place a melon on the scale, the spring stretches to 5.5. So you are simply putting in 5.5 into that and then subtracting your 6, and you end up with 5 pounds, right? 2.5 is 11, 11 minus 6, yeah. So you would get 5 pounds for the weight. And select all steps needed to verify that they are inverses. Well, remember with verification, we plug one into the other and you want to get your variable back. So if I was to substitute the inverse, the 2L minus 6 into the original, I want to get an L. And then if I go the other way, if I substitute the inverse, or sorry, if I substitute the new problem into the inverse, then I want to get W. I want to get my variables back. Okay, number 14. Is that on this one? Yeah. Okay, here is number 14. So in number 14, you had to decide, is the inverse a function and what it would be. Well, if I was to graph this, I don't even need to know where it is. I know it's a quadratic, it's a square. So this actually fails the horizontal line test. Remember, if a horizontal line was to cut through your function, your graph, does it touch in more than one spot? Yes, it does. So it fails it. So this one is not a function. It doesn't mean I can't find the inverse. I still can. Okay, so I'm going to switch places of my X's and Y's and then solve this. Start by adding 5 to both sides. You would then divide by 2. And then remember, to get rid of the square, you square root it. And when you square root something, you have to put plus or minus. So if you got that wrong, it is probably because you forgot your plus or minus in front of your radical. Remember, any even radical, I need to have a plus or minus in front of. Okay. And then the very last question was, again, another word problem. It was number 20. It was the very last question in the problem. So again, we're going to take our given function. Don't let these decimals scare you. You know how to work with values. You're going to divide first. Again, we want to get h by itself. So you're going to have a over this whole big thing. Okay. Now, in order to get rid of this power, 2 ways you can do it. You can put this as a root of that crazy looking thing as one way. Another way you can get rid of powers, by the way, is remembering the fact that I can rewrite radicals as fractional exponents. And that is actually how they wanted it written in this case. So I would have the fraction of a, and then I would raise it to 1 over this fraction, 0.3964. Remember, this is the same as this, but we don't tend to like to have radicals with decimals in as our index. Doesn't make sense. But we do know how to write things as rational exponents, and that's what you would want to use. So anytime you want to get rid of any crazy looking exponent, just raise it to its reciprocal power, or 1 over that number. It's the same thing. Okay, so that's your inverse. Again, just to double check that things are inverses, you would substitute a into the function and then the function into a. So it's these two. You got to plug them both in. And again, we're not looking for x in the word problems because there's no x in these. So we're looking for the other letter. Okay, and again, the last part is just about using this equation. So you would simply plug in, right, to estimate the height. That's what you're looking for, h, of a 60 kilogram person who has a body surface area of 1.6 meters. Well, you plug 1.6 in, put it in your calculator. It is going to come to about 150.1 centimeters. Okay, hopefully that cleared up some of the mistakes and some of the errors that I saw throughout.